Hi, so we're in chapter 10, wave particles are properties. In here, we're trying to prove that particles can also behave like a wave. Okay, macam mana nak tahu dia boleh jadi wave is just when they have a wavelength. Ada wavelength je, dia boleh jadi wave. So first of all, we have wave particles duality here. So wave particles duality, at certain time, a particle exhibit wave properties and at other time, it has particle properties. Okay, but we cannot observe both behavior simultaneously. In other way, nak senang ingat, wave particle duality, dia boleh jadi wave, can tunjuk boleh jadi particle juga, tapi it cannot happen at the same time. Okay, boleh tunjuk wave properties and also particle properties, but it can't happen at the same time. Okay, then kita ada de Broglie wavelength. As this equation, basically kita nak relatekan lah wave dan particle tersebut. So kita ada lambda equal to H over P. Okay, so this is the equation. So lambda exhibit wave properties. H is a Planck constant, 6.63/10^34. P is the momentum, which is exhibit particle properties. Okay, those who have mass, those particles has mass, so eventually dia akan ada momentum lah. Okay, then H, because P equal to mv, kita boleh ikutkan ini juga. So P is a momentum, lambda is a wavelength, mass is a mass of the particles that we're referring to, V will be the velocity. Okay, so kita ada electron diffraction. Basically for electron diffraction, kita ada one experiment to prove that electron ni can act as a wave juga. Okay, first, then kita ada Davison-Germer experiment. There one year they're asking for the name of the experiment. So kenapa ni? Davison-Germer experiment. So the main point of the experiment is to demonstrate the scattering of electron by graphite film. Okay, so dia nak scattering of electron ni. So bila electron not scattered, dia akan menghasilkan diffraction pattern. So basically we are observe diffraction pattern. Okay, kalau in this case, basically diffraction pattern ni dia exhibit as a intensity of the appearance of the electron. Okay, so kalau kita tengok dalam setup ini, so basically kita ada power supply. Okay, then power supply this is tungsten filament. So kita ada anode dekat sini sebab ni is connected to the positive terminal. Okay, so here eventually going to be negative terminal. So here we're doing in this vacuum chamber supaya we can detect all the electrons sahaja. Okay, so basically apa yang jadi dekat sini, tungsten filament ni ataupun graphite film, kita akan letak dekat sini. So kita akan panaskan dia, kita heat up the filament. Okay, kita akan panaskan tungsten filament ni supaya dia boleh release electron. Okay, so first kat sini kita akan panaskan supaya elektron dapat keluar dan sampai kepada anode. Okay, apabila dia kat sini, so here is a negative terminal, kat sini adalah positive terminal kan. So bila ada differences in the potential, where the potential difference between this part here dekat sini dengan sini, okay, ada potential difference. Apa yang jadi, elektron ni tadi dia slow, dia akan lagi laju dekat sini. In between these two, elektron akan makin laju, accelerated lah. Okay, by varying, so kat sini electron for heated up filament. So dekat sini dia akan panaskan supaya keluar elektron. So dia akan lalu antara potential difference between here. So electron will be accelerated. Okay, lepas tu dia akan pergi kat nickel target. Okay, allow to hit nickel target. The electron detector was mounted on the out, so it could be rotated to observe electron at different angles. Okay, so kat sini basically supaya dia boleh cover banyak angle lah, basically tu je. So dia akan bergerak up and down. So dekat detector ni kita akan nampak scattered electron. The scattered electron basically dia akan rupa macam ni lah. Sorry, dia akan nampak dia punya intensity dia akan berbeza. So daripada sini kita nampak dia punya projections of diffraction pattern of the electron berdasarkan intensity inilah. So basically kita tak nampak exactly yang bulat-bulat tu macam the wave pattern, tapi kita nampak dia punya saturations of electron berbeza. At certain angle, saturation electron dia lagi tinggi, lepas tu lagi rendah. So yang inilah kita boleh membuktikan bahawa electron ni boleh jadi wave juga. Okay, saya ulang sekali lagi. So first kali kita akan panaskan tungsten filament ni supaya dapat release elektron. Then dia akan lalu in between negatif dan positif, cathode dan anode. So dekat cathode anode ni akan ada kat sini akan ada potential difference. Okay, dia akan lalu potential difference. So apa yang jadi, dia akan accelerated dekat sini. Lepas tu dia akan pergi targeted on nickel target. Kenapa nickel target? So because basically nickel target ni we act as diffraction grating. Kenapa ia act as diffraction grating? Adalah kerana this is a solid kan. Kalau solid, dia punya structure macam ni. Sorry lah, betul rapat kan. Okay. So because the structure of the solid is close by each other, so what happen? Bila electron lalu kat tengah-tengah ni, so basically the gap dekat tengah-tengah ni akan act as diffraction grating lah. So this is very small, so dia banyak. So sebab tu kita akan nampak scattering dekat detector. Right? So at observation, at certain angle, there was a peak in intensity. Okay. The intensity of the scattered electron beam exhibit clear minima and maxima. So kalau minima dan maxima ni kita boleh cakap sebagai diffraction grating lah. Diffraction pattern. The pattern was observed to be similar to a diffraction pattern observed when wave was passed through a crystal atom. So sama juga crystal atom ni adalah yang act as diffraction grating. Okay, this establishes the fact that electron have wave-like particles. Okay, so dia punya, kenapa dia particle? Sebab dia ada mass dan juga dia ada speed. Okay, kenapa dia boleh jadi wave? Because dia boleh menghasilkan diffraction pattern. Okay, menghasilkan diffraction pattern. So dia kata kat sini, if the velocity of electron is increased, so V increase, the rings are seen to be narrower and showing the wavelength of the electron decrease. Maksudnya kalau kita kata pasal, ni bukan pasal electron so kalau pasal biasa, diffraction pattern ni, kalau dia besar macam tu, okay, so distance between here will be the lambda lah. Okay, so kalau yang ini dia kata narrower, kalau lagi laju dia lagi rapat ni. So bila dia lagi rapat, means that the wavelength will decrease. Right? Okay, so next. So kita kat sini kita ada electric. So apa equation yang kita ada? Tadi kita lambda equal to H over P ataupun lambda equal to H over MV. So dekat sini basically what happened during the Davidson-Graham experiment. So elektron awak kita lepaskan. Okay, bila dia lepaskan, dia lalu dekat potential difference between anode dan cathode. So bila lalu dekat situ saja, dia ada electric potential energy. Okay, so ni adalah chapter 1 lah. So electric potential energy ni all will be converted into kinetic energy. Okay, daripada dia lalu electric potential, dia lalu potential difference, those electric potential energy tu will be converted into kinetic energy. So U equal to K. Okay, so kalau U ni, kalau ingat balik, U ni adalah QV. Okay, sebab Q kita is a charge of the particles which we are using electron. So U equal to EV. So half mv square. Ni mass electron lah. So kita gerakkan 2 ke atas. So 2 EV equal to mv square. So I times both parts by m. So 2 MeV, m square v square. So jadi 2 MeV. Ni momentum square lah. So h square over lambda square. So from there we can calculate that the wavelength of the electron is lambda equal to h over sed 2 MeV ataupun h over sed mu. Kenapa? Sebab dekat sini this part here adalah U equal to QV. Okay, so basically V besar yang beza V kecil ni adalah velocity. So V besar ni adalah velocity. Okay, capital V is electric potential. So M is a mass of electron, E is electron charge, so U is electric potential energy. So this equation is specific untuk electron. Kalau ada particles lain, so lambda equal to H over sed 2 M QV besar. Okay, ataupun sama yang inilah H over Z 2mu. For other particles, alpha ke, beta ke dan sebagainya, so mass ni will be the mass of the particles, so Q will be the charge of the particle. Okay, so be careful, put in mind that small v is the velocity, capital V is electric potential. So last, kita ada electron microscope. So in comparison to kita ada optical microscope yang menggunakan lab, bio, semua tu. Okay, so kalau electron microscope ni basically we're using electron lah. Okay, so kita ada this is transmission electron microscope. So kita transmit electron awak. So kita tengok dekat sini kita ada hot filament. So hot filament ni will act as a source of electron. So kita sama macam tadi lah, kita akan panaskan kawasan ni dan to release electron. So dekat sini kita akan guna very high voltage. Kenapa kita nak high voltage? Supaya apa? Higher speed will be produced. Okay, dan kita ada condensing lens. So dalam electron microscope ni kita guna glass lens sebab electron tak boleh melepasi glass. Okay, so kita akan guna electromagnetic punya lens. Okay, so it's very high voltage. So to increase the speed of the electron, dan ada condensing lens. Lepas tu kita akan letak spesimen kita dekat sini. So you nak letak biopsi apa-apa, sel ke dan sebagainya. So apa yang jadi, electron akan pass through your specimen. Dia akan lalu another lens. Dia akan banyak lens dia lalu ni supaya dia akan fokuskan untuk menghasilkan image on the screen. Okay, ataupun kita boleh guna film ataupun semiconductor detector. Okay, so this is a complicated part. The easy part is electron behavior in electron microscope adalah electron will be accelerated through a high potential difference. Okay, so you put in mind accelerated through a high potential difference. So dia akan ada very high speed. Okay, apabila velocity very high, electron ni akan ada very short Debye wavelength. Sebab apa? Lambda equal to H over mv. Right, so bila speed awak tinggi, lambda awak akan lagi rendah. Right, resulting in high resolving power. So bila lambda resolution kan, awak pernah belajar kan yang kita 1080, 365 kot dan sebagainya. Kalau kat YouTube tu kan awak pilih-pilih kan. Okay, yang paling rendah tu selalunya dia besar-besar. Okay, bila HD ke 1080 pun is very sharp. Okay, very sharp tu maksudnya you can see kalau dia ada jerawat ke apa kat muka, dia boleh nampak. Sebab apa? It's very high resolution. So because lambda dia rendah, you can go very specific, very detail on the structure. Lambda rendah lagi bagus lah untuk kita tengok. Okay, tetapi lambda ni is inversely proportional to resolving power. Kat sini lah. So maksudnya kalau lambda tinggi, resolving power dia rendah. Which is good lah. Okay, so diffraction effect of electron as a wave is much less than the visible light. Okay, kenapa? Kalau kita tengok kat sini, nanti kita buat calculation. Lambda of electron ni lagi kecil berbanding dengan lambda light. Kalau lambda light, saya cakap, kalau lambda ni 10⁻⁷. Okay, lambda electron will be much smaller than that, 10⁻⁹. So bila dia lagi rendah, dia lagi boleh look more details. Okay, so apa betternya electron microscope compared to optical microscope? So first of all, it can distinguish details about 100 times smaller sebab lambda dia berkurangan sebanyak 100 kali. Okay, the resolving power is much higher. Okay, ingat lambda is inversely proportional with resolving power. Can produce 2 dimension dan juga 3 dimension image. Okay, so that's about it for chapter berapa kita ni?